Hi, my name is Justin, and I will walk you through a process of creating such building. There will be two variants, one with Steampunk and the other without. For modeling, I will use Blender 3.0. The entire process, from a sketch to final result in Unreal Engine 4, should take about 4 to 6 hours, depending on how complex your drawing will be. I provided my own sketch, all models and textures, as well as a Blender file for you. The download link is in the description down below. The structure of this video. 1. Sketch, where I explain how to make it and how to set it up in a Blender scene. 2. Blockout, how to create a simple geometry composition based on a drawing. 3. Decoration, the longest stage, where I show how to decorate the simple blockout with modular pieces. 4. Unwrapping, UV mapping of textures for the newly created surfaces and light map mapping for the baked light information. 5. Collision, normals, names. Short but important step to get your model prepped for the export. 6. Export, import. Moving finished meshes from Blender to Unreal Engine with the correct settings. Over 360 models, such as this one, from large buildings, steampunk engines and pipes, smaller modular pieces as well as landscape elements are available in my most recent asset pack for Unreal Engine 4, called Steampunk Town. More information on that is in the description. Let's get started. Sketch. I drew the building from two different sides in orthographic projection. Shapes are drawn with simple lines without shading, just to convey an idea. For your own building you can use my drawing, but I encourage you to create your own. All you need is an idea, pencil, rubber and a piece of paper. When it's finished, take a photo of it and drag and drop it into a Blender scene in the front orthographic view. Let's scale it up so it roughly matches the size of modular pieces and a template in the back. Now you're ready to start modeling. Blockout. Still in the orthographic front view, let's begin by adding a simple plane, or cube if you prefer. In this case, I use a plane, which I rotate to face camera, and then in the edit mode with edge selection I transform the edges to construct walls. My eyes travel from a drawing to the geometry, back and forth, to make sure that the model truly represents proportions of the sketch. I align edges of the walls to the template in the back, so that each level has the same height. For cylindrical steampunk elements, I add a simple cylinder with 20 sides, rotate it, scale it up and reposition, first in the orthographic view, so it matches the drawing, and then in the perspective view, so it is roughly the same place as a wall. Back in the orthographic view, I duplicate walls by selecting them and pressing Shift D. This way I can quickly add higher floors of the building. I move edges of the walls outwards to build Gothic-like overhang. Higher levels extend beyond lower ones. Later on, when I decorate this blockout, I can place nice bracket beams or dogung in those overhangs. In a perspective view, I extrude edges of these walls in a perpendicular direction to create adjacent walls, ceilings and floors. I keep one eye on the drawing and second eye on the 3D model to make sure I stay on track. I try to keep a clean topology, and where needed, I merge overlapping edges with M, bridge gaps with F, and align edges with scaling S in one axis only. When I need to create a face across more than two edges, I select all of them, press F3 and search for bridge selected edges. Now the time has come to create pipes. For straight ones you can use cylinders that are just rotated, scaled and extruded. But when on your sketch there are curved pipes, you need to use Bezier curves. In one of the orthographic views, press Shift A and choose Curve Bezier. Then in the edit mode, drag its point so that the curvature matches the drawing. Each pipe has its thickness. In order to set it, select the curve and under Object Data Properties in the Geometry tab, change the depth parameter to something like 1 meter. Now continue adding walls, generators and pipes until you are happy with the composition. Do not force yourself to make the model exactly as in the drawing. Be sure that the building presents itself well from every perspective. For the curved demon-repelling roofs, it is good to start with a plane on which I add a loop cut with Ctrl R and drag it upwards to create so-called a gable roof. The curvature is added by creating additional loops on both slopes. To turn a simple gable roof into a Dutch gable, create a curtain wall with F and extend the bottom edge outwards like so. For the top beam called ridge, I add a simple plane which I squeeze in Z-axis and then extrude one of its ends in a curved fashion. I duplicate it on the other side with Shift D and scale it along y-axis with value of -1. Flip its normals with Alt-N, flip, and merge disconnected vertices with M. As for the roof of a little tower, I can actually start with a cube this time, and in the edit mode, scale the top face down to create an apex. Then, by adding several loop cuts with Ctrl and R, I control its curvature and can even model a pinnacle in somewhat Gothic style. For the balcony, we will use planes again, this time without rotating them. To make the balcony more interesting, I extrude the plane alongside a wall of the building, and then make it turn with the corner of the building. As for the terrace, I will extrude a little portion of it outside the boundaries of the stone base, and then extrude it again, diagonally alongside the stone wall, basically creating a ramp. It will have a little stop in the middle for people to rest on. Good job, the blockout is finished. Alright, let's start with beams. There are 3 different lengths here, the top one having additional loop cuts. This one can be used for curvatures. I copy a beam with the right length and drag it over to the blockout. For every wall I will put a beam on the top and the bottom. Same goes for the little overhangs. For vertical support of those structural beams I use one of the columns, which I duplicate with Shift D and position on all the corners of the building. Some of them also go in the middle so that walls are separated. Once all beams and columns are placed, let's go ahead and add some roofs. Among the modular elements there is a piece of a curved roof with its Bezier curve. I will duplicate both of it, move them over to the blockout roof and adjust the curvature by entering edit mode of a Bezier curve and repositioning the handles. I have to make sure that I do it from the orthographic view so that the curve remains planar. Otherwise the roof mesh will go all over the place. For each roof that is placed, I remove the corresponding blockout element so that there is no overlapping. Once I have a roof where I need it, I need to cut it so it meets seamlessly with its adjacent roof. First I apply the modifier, then go to the top orthographic view, choose face select mode and turn the X-ray mode with Alt and Z and select the faces that will be cut. Then I go to mesh and bisect and draw a diagonal line across the roof tiles to create a cut. I expand the bisect settings and choose clear outer or inner depending on the direction of the cut. Just keep in mind that this will create n-gons, meaning faces with more than 4 vertices along the cut. Let's ignore that and move on. For the upmost beam of the roof called ridge, I used a swan-shaped beam. I place it on one side and then I add this random sphere above it, roughly in the middle of the roof. I select the ridge and in its modifiers tab I pick a mirror modifier. Then in the settings I change the axis to the correct one. In this case default x-axis should be fine. Choose the x bisect as well so we do not have the weird overlap. By moving the floating ball I adjust the length of the ridge. When ready I just apply the modifier. There might be some weird shading but let's worry about it later. Alright, the building is progressing nicely. It is good time to bring some steampunk to the mix. Those big cylinders are easy. All I do is duplicate the one that fits the best, position it where the blockout is, and remove the corresponding blockout geometry, and also make sure that there is no weird overlapping with the rest of the building. Some of these steampunk elements can be animated later in Unreal Engine 4, but let's not worry about it now, and move to the curved pipes. Firstly, let's select those Bezier curves and change their settings a little. Under Object Data Properties, let's crank up the resolution to the maximum value 64, and down where the geometry is, set the depth back to 0. Now let's enter Edit mode and separate individual curves. For each of them, go ahead and adjust the pivot point to one of its ends. You can do that by selecting a handle on a curve's end, and then hitting Shift and S, choosing the cursor to select it, and back in the object mode, set origin to the 3D cursor. And now the little orange dot should appear where the cursor was. Let's select the pipe you like the most and duplicate it. Press Shift S, selection to the cursor, and it should teleport to where the 3D cursor was, and now the origin point of the curve is. Go to the modifiers tab and choose the curve modifier and pick the Bezier curve to be the guide. Each pipe should already have enough topology to follow tight turns of the curve. If the pipe looks like it's drunk or something, choose a different deformation axis in the modifier properties. Now if you move the pipe along the z-axis, it will go with the flow of the curve. This way you can choose which part of the pipe will be visible. Repeat the same workflow for all remaining pipes. Before removing unnecessary parts of the pipes, you need to apply the modifiers, and then in the edit mode, select faces to be removed, best to do it in the X-ray vision, and hit X to delete them. Last but not least are all the wooden panels, windows, doors and railings. If you have used the template to make sure that each floor has the same height, all these segments should fit like a glove. When I add a panel with some kind of window or opening, I then have to edit the underlying blockout wall so that there is a hole there to see through. All the wall segments that I made work both ways, from the outside and inside, creating the interior, which is nice. In some places I put wooden wall segments, in other places I leave a naked wall. It will have a plaster or wood planks texture. Let's quickly go back to adding beams, now that we have all the steampunk elements in place. I'll pick up the top beam with extra loop cut and duplicate it. Then I'm going to add a circle and adjust its radius and position. It will highlight the intersection between a wall and metal. Now let's select one of its handles in edit mode and Shift and S, cursor to selected, exit the edit mode and align the origin of this circle to that 3D cursor. You can do that by going to Object, Set Origin, Origin to the 3D cursor. Then I select the duplicated beam, Shift S, selection to cursor, and I can now add a curve modifier. Once I pick this circle as a reference object and choose the correct axis, the beam starts following the shape of a curve. I can now scale the beam along x-axis so it completes a full circle and add even more loop cuts in the edit mode so that it is less clunky and more smooth. All of the modular pieces are already UV mapped and textured, so I only have to worry about walls and floors of the building. I'm going to select what's left of the initial blockout, and in the material properties I will choose 3 materials: wall planks, wall plaster, and wall stone. You don't have to create them, they're already in the Blender file. Then I will choose which surfaces use which material and assign selected faces to the highlighted material. Here for a large base I'm choosing wall stone. In the edit mode I select one of the faces of the stone base, press Ctrl and L to expand this selection, and click Assign. Let's switch to the edge selection mode and select corners of a base. I'm gonna quickly add a bevel to those with Ctrl and B, so there are no sharp corners. Then still in the edge select mode, I turn one of the edges into a seam with Ctrl E, mark as seam. And with entire base selected, I hit U and choose Unwrap. Let's open the UV editor and see how it looks. First, at the top, I choose the 2D cursor to be a pivot point for all transformations. Then I change its position with a shift and right click somewhere in the UV square. Then I hit A to select all and R to rotate based on that pivot point. I move the wall down and then select vertices like so, and rotate them in a way that the bottom edges of the wall align roughly with the bottom of the UV space. To preview the result, I click on the viewport shading icon in the top right of the 3D window and choose Flat Texture. It will preview an active texture onto the 3D geometry without shading, just an image. It is by far the best mode in Blender for UV mapping and previewing the textures. Let's do a plaster wall now. I will select the wall segment I want to unwrap. Here I click on one face and Ctrl L to expand the selection. In the options I switch to Material, so that only faces with plaster material will be selected. Then U, Unwrap, and in the UV editor let's rotate it 90 degrees and scale it up so it fits vertically into the UV space. Horizontally you don't have to worry about the boundaries, since the texture tiles seamlessly in this direction. Similar workflow is for the rest of the shell. Once the UV mapping is done, for walls and floors I will add a modifier called Solidify without filling the rim. For the thickness I will choose 5 cm or 2 inches, and I will check even thickness, leaving the rest of the settings on default. I apply the modifier, and then for planked walls I will select just them. In Material Properties tab in the Edit mode I will click on the wall planks material and then select. And inside the UV editor I will go to UV Average Island Scale just to be certain that all planks have the same size. Probably some of the wooden beams are now slightly stretched or compressed. To fix that I will select all faces sharing the material Trims Wood and open the shader editor where there is a checker texture above other textures. If I click this texture, it will automatically swap the previous colors to a simple checker image in the 3D scene. Then, back in the 3D viewport, you can zoom in onto individual beams and see whether there is a stretching or not. Here, for this long beam, the squares stretched out. So, I select it in the edit mode, I go to UV editor and readjust the vertical scale along y-axis of this particular UV island. Okay, the model is almost ready to be exported. All structural elements are in place, all textures are now properly assigned and without any stretching. The last step is to determine the UV map for light maps to be baked in the engine, and also to create a decent collision. Let's start with a light map. When it comes to light map UVs, all modular pieces already have it set up, but now I need to set the light map channel for entire structure combined, another one for the shell, and another one for steampunk elements. These three models will be exported separately, and each should have a proper UV sets. I will pack the UV islands in the second UV channel using an add-on called UV Packmaster, but there is also a built-in feature for packing islands in the Blender. Let's begin packing by selecting the structural mesh. If it's still in separate elements, select them all and hit Ctrl J to join them. Head on to the object data properties and hit on the second UV channel called LM. Since lightmap UVs cannot have overlaps, we need to fix the UV mapping for this particular element. And select all the faces that share trims_wood material. Then let's press Shift and H to hide everything else. And in the object data properties, let's make sure that a light map LM UV channel is active. And then to correct all the UV stretching, just simply hit U and unwrap. In the 3D view, let's press Alt and H to unhide rest of the structure and hit A to select everything. Inside UV editor, press A again to select all the islands and head up to UV, average island scale, so that the textile size is uniform. Now let's pack it. You could do it in 3 ways. Manually, which would take about 2 weeks, so let's scrap that idea, using default Blender packing, or via a UV packing add-on, for example UV Packmaster. To pack them without add-ons, just select them and choose on the top UV Pack Islands. The result is good, but it could be better. Let's use UV Packmaster. Choose low margin, high iterations, enable rotation and scroll down and hit Pack. It might take a while longer than the previous method, but look at that. That's what I call a tight package. So you remember how we did the light map mapping for the first mesh? It is exactly the same process for the steampunk elements. However, it will be different for the shell. It does not have light map channel. So what we need to do is create a new one. Under the object data properties, UV maps, just press the plus icon and it will create a duplicate of the first UV map. You have to rename it into LM. Yeah, that's right. Activate it and go to the UV editor, and there you select everything with A, go to UV's average island scale, and you pack it just like before. Now that all the light maps are nicely packed for all 3 objects, structure, pipes, and the shell, it is time to create a collision. In the 3D viewport, still in flat texture shading, I begin with adding a cube for the stone base. In the orthographic views, I scale and center it and select the top face and scale it down uniformly. With collision prisms, it is important that they are convex, so instead of extruding the top face, I simply duplicate the entire thing, move it upwards, and then scale properly. While I do it, I keep in mind that these faces must remain planar. For the walls, I shift right click to place a 3D cursor onto the surface and add a cube, which I make very thin. Collision mesh has to engulf the building entirely, but it has to be simplified, not too complex, so that the player will not bump into tiny little protrusions in the game. When the main building is covered in low poly white blocks, it is time for the steampunk elements. Here I add a 20-sided cylinder. I rotate it, rescale it and place properly in the scene. As for the pipes, they will also use cylinders as their collision, but they will be 16-sided. They don't need to be as high poly as the larger steampunk parts. Straight sections of the collision prism are shorter, especially when the pipe curves, so you can fit them nicely along the curve. Again, the X-ray vision comes very handy, allowing me to clearly see both underlying mesh and the simplified one. Yeah, when finished, let's keep the collision of the building separate to the collision of the steampunk elements, just like models themselves. Last thing before exporting is to set the pivot points, normal maps, and names. Click on the walls and enter the edit mode. Now let's pick one of the bottom edges near the corner. Select it and set a 3D cursor to it with Shift and S. Then exit editing mode and select all meshes and objects and set origin to that 3D cursor. Then hit Alt and G, which will teleport everything to the world origin 000. Then apply a rotation and scale by pressing Ctrl and A. Now in object mode, let's select the collision and hide it with H, and change the viewport shading mode to matte cap and single color. Check if normals are correct. They most likely are not. There could be some weird shadows and smooth transitions where there shouldn't be any. You can fix that by selecting the mesh and picking the modifier weighted normal. Let's select both options, keep sharp and use face influence. And the only issue is that the shell mesh does not have any sharp edges. Let's add them now. In the edit mode, edge selection, go up to the select tab, select sharp edges and crank up the value to around 80. Then hit Ctrl and E and mark them as sharp. They should change their color to cyan. And with that change, normals of all meshes are now clean. Let's rename models now. Mesh containing walls, floors and stone base is called Building Tutorial Shell. Mesh containing all steampunk parts is called Building Tutorial Pipes. And last one, which contains all structural pieces and details, is named Building Tutorial Structure. Their corresponding collision meshes should have a prefix UCX underscore, and then the name of the mesh, and then another underscore and the number 001. For example, the shell will be UCX underscore Building Tutorial Shell underscore 001. That is the naming convention for Unreal Engine 4. Let's export all three meshes now. I will start with a structure mesh. Here I select first the collision and then the mesh and press Shift and H to hide everything else. I check if the pivot point is correct and the rotations and scales of both of them are applied. To check rotation and scale properties, hit N and see whether all rotations are set to zeros and scales are set to ones. Then File, Export, FBX, and let's adjust the export options. You only want to limit to selected objects and pick the mesh object type. As for transforms, let's pick forward X, upwards Z, and apply units. In the geometry tab, let's set smoothing to edge. This way you will preserve nice normals and smoothing groups. Check the apply modifiers checkbox in case you did not apply them yourself. When you scroll down all the way to animation, just uncheck it. We don't have any animation to export. Hit Export FBX and back in the 3D viewport, repeat the same for the pipes mesh and the shell mesh, with only the difference that the shell mesh does not have any collision. In the Unreal Engine 4, just drag and drop three meshes onto empty space in the content browser, and in the import options choose Remove Degenerates, disable Generate Lab Maps, disable one convex hull per UCX. You can turn off the compute weighted normals, since we already did that in Blender. Leave the convert scene on and keep the order material as the FBX materials on as well. And do not import textures or any materials. Hit Import All, and now you have all three meshes inside your project in Unreal Engine 4. In this video I will not talk about materials in Unreal Engine, but I will show you a few of them. Metal fittings material. This is the diffuse. This is roughness. Here's the metallic set to 1. Specularity set to 0.2, and the normal map. Here's the wooden planks material, the diffuse setup. Specularity is set to 0.25. This is roughness, normals, with normal strength set to 1, and the smudges. Thank you for watching this video. I hope it was useful for you. Do not forget to check out the asset pack on Unreal Engine 4 Marketplace. There are also nice 3D art pieces based on this asset pack on my Sketchfab. Stay safe and goodbye.